Hello everyone. Today we will be doing the experiment of the synthesis of hexaphenylbenzene. As you can see from the photo, there is a plexiglass set at a certain angle, and then there's a test tube also facing towards the plexiglass, and then there's a Bunsen burner, and there's a torch on the right. For this experiment, you need to work deep inside the hood with enough space to move the burner around. The plexiglass plate is used as a splash guard, and there must be no organic solvents present in the hood while the gas burner is on. First thing we'll do is to weigh out 0.1 gram of tetraphenylcyclopentadienone, and that's our reagent for this reaction. Transfer the tetraphenylcyclopentadienone that we weighed out to a test tube. Tap the test tube on a hard surface so that all the reagent falls onto the bottom. And place the test tube in a wooden block. Next, measure out 0.1 grams of diphenylacetylene. And transfer this diphenylacetylene into the same test tube. Measure out 1 ml of silicone oil using a mechanical pipette and pipette this into the same test tube. So that's the test tube containing the two reagents immersed in silicone oil. The outside wall of the test tube needs to be wiped very well so as to not let the silicone oil come into contact with the open flame. This is a precautionary measure since oil tends to be very combustible and we are working with an open flame. So we need to be very careful about not letting the oil come in contact with the flame. Use a clamp to position the test tube at an angle relative to the plexiglass as shown. Make sure that the joints of the clamp are tight since the test tube does not have any other support. The Bunsen burner is connected to the gas outlet. The first thing we do is to turn on the gas and use a torch to flame on the Bunsen burner. So the flame is on right now and the bottom of the test tube is exposed to the flame. The Bunsen burner is connected to the gas line through the black tubing, and so we turn on the gas and use the torch to turn on a flame. Even though the flame is not really visible on camera, there is a flame there that you should be able to see burning as the video progresses. We adjust the height of the flame. The flame needs to be small and blue. The flame, if it is too tall, the chemicals at the mouth of the test tube will catch fire. So you need to be very, very careful. After we adjust the height of the test tube and the intensity of the flame, we heat the test tube in this manner shown in the video for 15 minutes. During this time, there is a change in color of the reaction mixture that we will need to note down. The burner must be held at the base and the flame must be moved along to uniformly heat the reaction mixture. If the boiling is too much, as when the reaction mixture moves up quickly, then move the flame aside until the reaction mixture settles back. This needs to continue for 15 minutes. The product formation is evident by the change in color. The precipitate is expected to be tan or light brown color. This is what the test tube looks like 13 minutes later, around 12 to 13 minutes later. So when it is at this stage, we give it a couple of minutes and then we switch off the flame. The gas tap must be turned off at this point and the burner should be disconnected, and only then you should proceed to the next step of bringing other organic solvents. Leave the test tube at this stage until it cools down to room temperature. After cooling down, we detach the test tube from the clamp and then we add 4 milliliters of hexane to dissolve the impurities in the product before filtration. Use a glass rod to dissolve everything. Then we subject this liquid mixture to vacuum filtration that we have seen before. Add even more hexane to the test tube and then, really grind it up, mix it up as much as possible. And then we use toluene, which is another solvent, to wash the product. We use 4 milliliters of cold toluene to wash the product once more. So the only characterization that we will be doing for this product is to measure its mass. We will not be taking the melting point or be taking the IR. The reason we don't take the melting point is because the melting point of this product is way too high and our melting point apparatus will not go that high. So for mass measurement, while the product is drying, the first thing we do is to take the mass of the empty vial. Then transfer the product from the Hirsch funnel to the vial. Then measure the mass of the vial with the product in it. So that was it, guys. We have finished this experiment and now next is the cleaning part. We should throw away the solids in the solid waste labeled beaker at the right, and then we throw the liquid in the liquid waste. Then we clean every single glassware using acetone, and then we put it all in the liquid waste, and then we clean the glassware using GI water and throw away in the liquid waste. And if there is any broken glass, there shouldn't be if we did do the experiment correctly, since we did not take the melting point. So, but if there is any broken glass, we put it in the disposable glass waste. And also we clean our bench tops and where we did the experiment, the fume hoods, so that there is nothing left. And especially since there is oil, if there is an oil spillage, it's not going to go just by wiping. We need to use acetone and other organic solvents. Basically, if there is any kind of spillage, inform your TA. Also, the test tube where we did the reaction, that's called the reaction tube, that also needs to be discarded into the broken glass container. So that was it, guys. We have synthesized hexaphenylbenzene using a Bunsen burner or an open flame. I have never worked with an open flame before, so I hope it was fun to watch and fun to write a report on. and we have taken its mass, and we will not be doing any kind of any other kind of characterization like taking its IR or taking melting point or TLC. We will not be doing any of that, just the mass. So that was it. Thanks. Have a great day.